What if I told you that a tiny, glowing nuclear fly is quietly saving humans from flesh-eating parasites? It sounds like science fiction, but it's one of the strangest, most brilliant medical marvels you've never heard of. In this video, we dive into radioactive insects, parasitic nightmares, and the mind-blowing science that turns bugs into healers. Stick around to the end. The twist behind how they actually work will change how you see medicine forever. Let's kick things off with something that might make your skin crawl. Picture tiny larvae burrowing into your flesh, feeding on your living tissue. This isn't a horror movie plot, it's a real parasitic nightmare called myiasis, often caused by screwworms. These flesh-eating parasites don't just affect humans, they're a major threat to livestock too, causing billions in economic damage. But here's the kicker. These parasites aren't just a minor nuisance. In severe cases, they can lead to massive tissue damage, secondary infections, and even death if left untreated. The problem is, traditional methods like pesticides often fall short. They're not targeted enough, and parasites can develop resistance over time. Now you might be wondering, what does a nuclear fly have to do with all this? Well, it turns out that sometimes the solution to a problem comes from the most unexpected places. Scientists came up with a brilliant idea. What if we could use the flies themselves to fight the parasites? But not just any flies. We're talking about specially treated sterile flies. And no, they don't glow in the dark or have superpowers. The term nuclear here refers to the process used to sterilize them, not that they're radioactive. Let's think about this for a second. How exactly does releasing more flies help get rid of flies? It's all about disrupting their reproduction. Male flies are exposed to a carefully controlled dose of radiation that makes them sterile. When these sterile males are released into the wild, they compete with wild males for mates. Here's the interesting part. When a sterile male mates with a female, no offspring are produced. Over time, this floods the population with sterile males, drastically reducing the number of flesh-eating larvae in the next generation. It's like a biological form of birth control for the entire species. Now, I know what you're thinking. Radioactive flies? Isn't that dangerous? But, here's the thing. These flies aren't radioactive at all. The radiation is used in a controlled environment to sterilize them. But the flies themselves don't retain any radioactivity. They're as harmless as any other fly, except to their own species' reproduction. This misconception actually highlights an important point about nuclear technology. While it can be dangerous when misused, it also has incredible beneficial applications in medicine, energy, and yes, even pest control. It's all about how we harness and control it. In the 1950s, the United States and Mexico launched one of the most ambitious pest eradication programs in history. Their target? The New World screwworm, a parasite that was causing havoc among livestock. Using the sterile insect technique, they systematically released billions of sterile male flies across North and Central America. The results were astounding. By 1966, the U.S. was declared screwworm-free. The program continued southward, and by 2006, the entire North and Central American mainland was free of this once devastating pest. The success with screwworms was just the beginning. Scientists realized this technique could be applied to other parasitic insects too. Take the tsetse fly, for example. These insects spread sleeping sickness in humans and nagana in animals across parts of Africa. The sterile insect technique has been used to control tsetse populations in several African countries, saving countless lives. But it doesn't stop there. Similar approaches are being developed for mosquitoes that spread malaria, dengue, and Zika virus. The question is, could we one day use this method to eradicate some of the world's deadliest insect-borne diseases? The impact of the sterile insect technique goes far beyond just controlling pests. It's estimated that the screwworm eradication program alone has saved the North American livestock industry billions of dollars annually. But more importantly, it's prevented immense animal suffering and protected human health. In regions where SIT has been implemented, we've seen dramatic improvements in agricultural productivity, reductions in pesticide use, and better food security. It's a perfect example of how a clever scientific solution can have wide-reaching effects on economy, health, and the environment. Of course, like any technology, SIT isn't without its challenges. It can be expensive to implement on a large scale, and it requires ongoing releases to maintain control. There's also the potential for insects to develop resistance over time, but scientists aren't standing still. They're constantly working on improvements. One exciting area is the use of genetic engineering. Researchers are exploring ways to create insects that pass on sterility to their offspring naturally, without the need for radiation. This could make the technique more efficient and easier to maintain in the long term. As we wrap up, let's take a moment to appreciate the sheer ingenuity of this solution. Who would have thought that the key to defeating flesh-eating parasites would be more flies? It's a remarkable example of the power of thinking outside the box in science. These tiny, sterile insects are unsung heroes, silently protecting millions of humans and animals from gruesome parasitic infections. The next time you swat at a fly, remember, its cousins might be out there saving lives. This story of nuclear flies and flesh-eating parasites shows us that solutions to big problems can come from unexpected places. It challenges us to look at pests not just as problems, but as potential allies in improving human and animal health. Who knows what other medical marvels are hiding in the creatures we often overlook?